Electrical machinery 2. Subject. Topic. Speed control of motor. Electric braking. Electric braking for DC motors involves using the motor's own electrical energy to slow or stop its rotation. Three main methods exist. 1. Rheostatic or dynamic braking. Plugging or reverse current braking. Regenerative braking. First, rheostatic braking or dynamic braking. Another one of the types of braking is dynamic braking, which is also called rheostatic braking. This method of braking is generally less efficient because the generated energy dissipated as heat. Dynamic braking occurs when two things happen. One is disconnected from the power supply, and two, the braking resistor is quickly connected across the armature. The kinetic energy thus stored in the motor gets converted into electrical energy that turns into heat. Armature current IA, field current ISH, total current I, supply voltage V. Circuit shown in figure, that is DC shunt motor, and DC series motor circuit is shown second figure. Purpose of or connected across armature to dissipate heat power generated as a heat, that is hint. Analysis. IA is equal to EB divided by RA plus R. IA is equal to pi SN bracket of P divided by A bracket divided by RA plus R. IA is equal to K pi N, K1 pi N divided by RA plus R. TB is 1 divided by 2 pi N output power, that is torque, braking torque. First equations comes to N is equal to IA into RA plus R divided by pi SN P divided by A. Second equations comes to where TB, braking torque is equal to 1 divided by 2 pi SN P divided by A bracket divided by IA bracket RA plus R bracket IA square into RA plus R. TB is comes to K to IA, K2 into pi SN divided by P divided by A divided by RA plus R. TB is equal to K3N, that is comes to TB proportional to N. That is important equations in rheostatic braking or dynamic braking. DC series motor B, that is shown in figure. EB and IA field winding MN and rheostatic connected changing resistance IF field current. Dynamic braking, also known as rheostatic braking in a series motor, involves converting the motor's kinetic energy into heat by disconnecting it from the supply and connecting a resistor across the armature. This forces the motor to act as a generator, producing a braking torque that slows down. IF direction is no change, that is N to M. IA is change, torque is change. In DC series motor, we have to change the connection for performing dynamic braking, that is field current is reversed, that is the direction of field current is changed, flux is produced. Advantage, just replace the supply voltage via dynamic resistance. Subject. Electrical machinery 2. Topic. Electric braking. Second method of electric braking, plugging. Plugging or reverse current braking occurs when the armature terminals or supply polarity of a separately excited DC motor are reversed. As a result, supply and induced voltage end up acting in the same direction and ultimately provide twice the supply voltage. Plugging is considered inefficient because both the power supplied by the load and the source is wasted in resistance. Plugging braking in a DC shunt motor is a method where the motor's power supply polarity is reversed, causing the motor to generate a reverse torque that slows as can even reverse its directions. Shunt and series motor connection shown in figure. Field current is ISH, armature current IA. EB is back EMF, Plugging braking, also known as reverse current braking, in a DC series motor braking technique that reverses the motor's supply terminus. The reversal causes the motor to generate a braking torque, quickly stopping the motor. While it is a rapid braking method, it is also highly inefficient, dissipating significant power in the motor's winding. Analysis: IA is equal to V plus EB divided by R plus RE plus EB divided by R plus RA. IA is V plus R plus RA plus phi SN P divided by A R plus RA. There is no change in field current direction. IA is V divided by R plus RA plus K1 pi N divided by R plus RA. Braking torque TB is equal to 1 to pi N into output power. We are already known. TB is 1 2 pi into Z pi IA into P by A. TB is 1 by 2 pi is equal to pi into P by A into V divided by R plus RA plus K1 pi N divided by R plus RA. TB values we find 1 divided by 2 pi pi Z P A divided by N to V divided by R plus RA plus pi Z P divided by A into R plus RA. K1 is Z into P by A. Put this K1 value. We obtain TB equations. TB N we find K2 pi plus K3 pi squared N. TB is K4 plus K5 N. If N is equal to 0, TB is K4. Under standstill condition, we are taking same braking torque. TB proportional to N under no load speed. That is final equations we find out.